Okay, question 8 is another vectors question, but this is involving constant acceleration, which means we can use the SUVAT equations. It says that when t equals 0, the particle is at the origin. That's really useful because that means we don't have to worry about any position vectors from where it starts. It starts at the origin, so that's good for us. The velocity vector is 2i minus 3j. And it says when t equals 2, it's at point A, wherever that is. Well, we know where that is. That's 7 minus 10, so that's like here somewhere. So that's a position vector. That's an S or an R, depending on what letter you like to use. It wants us to work out the acceleration. So we have an S, we have a U, that's this, because that's when t equals 0, so that's the initial acceleration, the initial velocity, sorry. We don't have a V, we don't have a final velocity. We want to find the acceleration, and we have a time. We know where it is after 2 seconds. So the equation that involves S, U, A and T is that S equals ut plus a half at squared. These are vectors, so we can say that 7i minus 10j is equal to 2i minus 3j times 2 for the seconds, plus a half of a that we don't know, that's what we're looking for, times t squared, so times 2 squared, which we can write, that's going to be 4 divided by 2, so 2a. So let me simplify that to 2a. So we need to solve this now. If I expand those brackets, we've got 4i minus 6j. And if I move that to the left hand side, I'm going to take away 4i and get 3i. I'm going to add on 6j and get negative 4j. That's equal to 2a. So a is 3 over 2i minus 2j. And it asks us to show that the magnitude of the acceleration, this is the vector of the acceleration. So we need to find the magnitude, which we can do by doing the square of the I component, the square of the j component, and square rooting. Hopefully this is 2.5. Yeah, 5 over 2. Okay, for part B, it then says that when it leaves point A, so if you remember, it started at the origin, it went to 7 minus 10, and then it's now changing its acceleration to a new constant acceleration, and it's heading off to B, and it says that B, when it gets to B, its direction of motion is northeast. So it's heading off in that direction. So that's some, that means the velocity is going to be of the form some multiple I plus j. That's that northeasterly direction. Okay, so it's SUVAT still because it's a constant acceleration. So the constant acceleration is now 4I plus 8.8 j. And we know that the final velocity, we're looking for a time, we know the final velocity will be of some of this form. We don't know anything else. We don't appear to know anything else. But what we could find out is we could find the initial velocity out. That will be the same as the final velocity from part A. So when it got to A, when it got to this coordinate A. So if we find the velocity here in component form, in vector form, that will be the u for this new part. So let's start off by doing that. Let's say that v is equal to u plus at. We know a now. We know a is 3 over 2i minus 2j. So v will be the initial velocity, which was 2i minus 3j. We know the acceleration, we worked that out to be 3 over 2i minus 2j. And we know the time it took to do that was 2 seconds. So if we work this out, we're going to get (5i minus 7j) for the velocity. So that will be now our initial velocity. That's going to go in here. So we've got an equation again linking v, u, a and t. However, so we can put this together now. We've got two unknowns. We don't know k and we don't know t, but because we've got two components, because we've got i's and j's, we should be able to make a pair of simultaneous equations. So the fact that there's two unknowns shouldn't be a problem. So using this again, we're going to do v equals u plus at. V is going to be ki plus kj. U we've just worked out to be 5i minus 7j plus t lots of the acceleration, which is 4i plus 8.8j. So if we look at the I components first, then we'll have that k needs to equal 5 plus 4t, and if we look at the j's, we're going to have that k needs to equal minus 7 plus 8.8t. If we subtract those equations, the k's will disappear So 5 minus minus 7 is going to be 12, and 4 minus 8.8 is going to be minus 4.8. So t is going to be 12 over 4.8. Which is 2.5 seconds.